Let's begin. Today's daily Turing machine puzzle has 5 criteria cards in green and is using the blue verification color scheme to give us our responses. Let's take a look at what the puzzle looks like. Okay, so there we have our 5 criteria cards and our verification cards at the end, and we can begin with a proposal of 314. So let's see how that plays out. Okay, so we have 314 as our proposal. Let's look at our verification cards, or criteria cards. Our first criteria card is counting the number of 4s in our solution. Remember, we have a 3-digit solution. All numbers are 1 through 5. Criteria A is letting us know whether there's going to be 0, 1, 2, or 3 4s in our solution. B criteria is comparing the middle and the last digit, the square in the circle, and seeing which one is bigger or equal to the other. So a square less than circle is square equal to circle, or a square greater than circle. Criteria C is verifying which is the absolute smallest, right? Which is the smallest? Is it the triangle that's the smallest, the square, or the circle compared to the other two? Criteria D is counting how many evens, is verifying how many evens there are in our solution. Is there 0, 1, 2, or 3 even digits in our solution? And lastly, criteria E is sort of comparing the first two. Is the sum of the first two digits, triangle and square, is the sum less than 6, equal to 6, or greater than 6? Remember that our 3-digit proposal needs to meet all of these 5 criteria. So we're looking for that one unique 3-digit code. Okay, so I like to think of, in general, what could our solution be? So I'm going to ask how many even digits there are. So that is criteria D. So let me type in D. And yes, there is an even, a single even, because in my proposal I only have one even, and the Turing machine confirmed that there is a single even. So in my notes for criteria D, I will state that there is one even digit, and similarly that means that there are 2 and 2 odd digits. Okay, there's 1 even digit and 2 odd digits. At this point, I don't know where they may go, so there's really nothing I can eliminate above. So let's move on. Well, there is criteria A. Criteria A is verifying whether there's a 4 or not. We already know that there's only 1 even digit. Could it be a 4? Let's take a look. So criteria A tested confirms positive. Yes, there is a 4. So that means in my notes for A, we will state that there is a 4. So there is 1 4. And at this point, since we know that the even is 4, that means I can actually eliminate all the 2's from any of either the triangle or square or circle. Since the only even is a 4, can't be any 2's. Okay, moving on. So what else can we test? Well, let's figure out which is the smallest, and that would be criteria C. So let's see, what is the smallest? Okay, well, so it is incorrect. If I look at my proposal, the smallest digit that I have is a square. And so that means that is incorrect. Square is not the smallest. So in my notes for C, what I'll do is I won't say that C is the smallest. I'll just say either the triangle or the circle must be the smallest. Let me do that. So I'm going to put in my notes that either C or meaning the triangle or the circle is the smallest. So let's do that. I'm going to bring down a circle here, and let's state that triangle or circle is the smallest. Okay, don't know which one just yet. Okay, so I've already used my 3 criteria per turn, per round, per proposal. So that means I have to come up with a new proposal. So the 2 criteria that I have not tested are B and E. So if I focus on E, we're comparing that the sum is either less than, equal, or greater than 6. At this point, I really have no grasp on what it could be. So I'm just going to test 1, 5, 4. So I'm verifying whether the sum is 6 and see what happens, because there's just too many possibilities. So 1, 5, 4. Okay. So that's my proposal. So yeah, so let me test criteria E. Okay. So it is not correct that the sum is exactly 6. So for criteria in my notes for E, I will state that the sum is not 6. So the sum is not 6. Okay. And that in itself, I don't think helps me eliminate anything. So let me go to criteria B and compare compare the square and the circle and see if that's correct. So what does B tell us? Okay, B is correct. So let me look at the proposal, and since it's correct, if I compare my square and the circle, I'm basically saying yes, square is greater than circle. So the Turing machine confirmed that square is greater than circle, and that's for B. So I'm going to come up here and write down here that yes, square is greater than circle. So square is greater than circle. So let me type that up. Square is greater than circle. And I think that will help us eliminate some possibilities. So if square is greater than circle, that means square can't be 1, right? If square were 1, then circle would have to be a negative, or 0 or negative, and that's obviously not possible. So let me eliminate 1 from square. And similarly, I think we can eliminate the 5 from being the digit in the circle, because then, well, there would be no larger number for square to be. So I think we can eliminate 5 from being circle. Okay, so that's that. Is there anything else? Let's see, we come back here, triangle and circle. Yeah, I guess they potentially can still be the smallest. Okay, there's nothing there. Okay, so let's since we haven't confirmed C and we do have one more opportunity to test something, let's actually go back to C and see and see which of the triangle or circle is smallest, since I did choose 1 to be the smallest. Okay, so let's do C and let's confirm. Okay, it is correct. And so if I come back here, my proposal has that the triangle is the smallest. So let me update my notes for C to state that it is indeed the triangle that is the smallest. So triangle is the smallest. So that means if triangle is the smallest, obviously it cannot be 5. How can triangle be 5 and be the smallest? Not possible. Okay, so if triangle is the smallest, well, that means that circle is not the smallest, and it cannot be a 1. Cannot be a 1, yeah, cannot be a 1. So let's eliminate that. And what else? So triangle's smallest. Okay, so let's see. Well, okay, let's confirm. Can triangle be a 4? Well, if triangle's a 4 and it's got to be the smallest, that would mean that square would have to be a 5, but in turn, square has to be bigger than circle, and so that would then lead circle to be either 3 or 4, which would mean that triangle is not the smallest. So that means that 4, the triangle cannot be the 4. Triangle cannot be the 4. Okay, and remember, we do need a 4, and we still have a 4 in the square and circle, so that's still a possibility. Okay, well, we've used up our 3 tests for this turn. We have to come up with a new proposal. So it may be a good time to start listing possibilities. So let's go down here. We don't have a criteria F, so I'll just write some notes down here. Let's assume that triangle's the largest it can be, which is a 3. So if triangle's a 3, I don't think we can choose square to be 4, because then 4, again, square in turn has to be bigger, and that would lead circle to be 3, and so that means triangle wouldn't be the smallest. So that means a 4, a 3, 4 is not possible. So that would mean that it would have to be 3, 5, and 4. Yeah, we do need a 4. It can't be the 3 because we kind of said the triangle is a 3. So 3, 5, 4. So 3, 4 failed, not possible. So 3, 5, 4. And that looks like it's the only possibility for a triangle 3, right? 3, 5, 4. Okay, so let's do triangle 1. Okay, so it can't be 1, 3 because obviously there's no smaller circle. 1, 4, 3. Okay, so 1, 4, 3 seems to be a possibility, and that I think is the smallest, where triangle is 1 and square is 4. 1, 4, 3, yeah. So let's move on to 1, 5. So 1, 5, and it could be 1, 5, 3, and it could be 1, 5, 4. Okay, so it seems like we're down to 4 possibilities for a new proposal. Let's see if we can eliminate anything. Okay, so I do notice that 1, 5, 4 cannot be because we said that the sum cannot be 6. 1 and 5 is 6, so that means 1, 5, 4 is not valid. What else? Okay, I noticed that 1, 5, 3, we did say that there has to be a 4. There's no 4 in 1, 5, 3. So we can eliminate that. Okay, so we're down to 2 possibilities, 3, 5, 4, and 1, 4, 3. What makes them different? Well, again, we haven't really figured out what E is, the sum. And so 3, 5 is 8, that is greater than 6. And 1 and 4 is 5, that is less than 6. So that, it just comes down to a 50-50. Is the sum smaller or larger than 6? Well, I'll try 1, 4, 3 as my new proposal. 1, 4, 3, and hoping that the sum is less than 6. Let's see. 1, 4, 3. Okay. And again, I am confirming that the sum, so criteria E. So let me test E and see. No, it is not less than 6. So 1, 4, 3 is not, can be eliminated, so it cannot be our solution. So let me type in our, what we believe to be the solution of 3, 5, 4. And before we go to the Turing machine, as a last sort of check, I want to verify that 3, 5, 4 seems to, that it definitively meets all these criteria. So is there a 4? We said that there was a single 4. And yeah, there's a 4 in our solution. For B, we said that the square has to be greater than the circle. And yeah, 5 is greater than 4. The absolute smallest we said was triangle. And yeah, out of the 3, triangle is the smallest. Is there an even? Well, yeah, we have that 4. And we sort of, by process of elimination, well, no, actually we did confirm that the sum can't be 6 and it can't be less than 6. It's got to be greater than. And yeah, 3, 5 does meet that criteria. So based on that, it seems that we should be Okay, let's confirm with the Turing machine. So again, our solution 354. So let's test the code 354, and let's verify. Yes, congratulations, that is the correct code. All right, so now the question is, did we beat the machine? So let's come back here. Our first three tests were ACD. So let's verify that. ACD. A was correct, C was incorrect, and D was correct. ACD. Let's now go to the second, and it's BCE. BCE. New round, BCE. And E was incorrect. And we did have one last round, and that was testing E, and it was incorrect. So E was incorrect. And let's verify. Okay, well, we met the threshold, and we got our answer in less or 7 questions, just like the machine. So it's a win. It's a success. All right. Well, thank you. That was today's puzzle. Have a great one.